Right now, we're going to start a review session for the math quiz for General Chemistry 2, right? Going over topics that really you should know before entering General Chemistry 2. So I give a quiz on these topics the second week of class, right? That quiz is available for 24 hours later today. And once you click start, you have 20 minutes to finish 12 multiple choice questions on things like properties of logs, quadratic formula, exponents, square roots, etc. So we're going to cover all those topics right now, kind of quickly. And afterwards, if you have follow-up questions or want more practice problems, we can do those. So this is the review session for the math quiz for General Chemistry 2. Now, I give this during the second week of class because I've noticed in teaching that if I wait till week 6 or 8 when we start using quadratic formula, that's when the students realize I don't know the quadratic formula, and that's a problem. So now I give it in week 2, right, as a way for students to get some feedback on what they do and don't know and to brush up on these skills, because you don't want the math to be what slows you down later on in the class. So square roots is the first thing we're going to talk about. You've heard of these, right? Square roots undo squared terms, right? So basic algebra is solving something like this: x squared equals 25. Well, you take the square root to solve for x, right? X equals 5. Easy, easy. If only that were the type of question on the exam, okay? The type of question on the exam might have higher order roots. So square roots you might be comfortable with, right? But maybe you're not so comfortable. Write this out a little bit cleaner. That's a square root. You take the square root of each side, and you identify x is 5, right? Although it could be, right? There's actually a couple solutions here, but we're not too concerned with, negative roots, imaginary numbers, these types of things, although we'll touch on those later on. Okay, so the higher order roots undo higher order terms, okay? So you could try to solve for something like this: x to the 5th equals 1024, right? You don't want a square root, okay? You want a 5th root of this, right? Just like if something is cubed, you want a cube root to undo the cube, okay? So the problem for most of the students is that they're using a calculator that they've never had to take a 5th root or a cube root or something before, right? So get the calculator out that you're using on exams right now and find this button on your calculator, right? This button on your calculator denotes some other root besides square, right? And so usually you would type on your calculator 5, and then you would type this button, right? And then you would type 1024, right? To do the 5th root of 1024. Okay? And when you do that on your calculator, you should get, I believe, x equals 4. Right? 4, 16, 64, 256, 1024. So just to check, 4 to the 5th power is 1024. That looks right. Okay? So I just want to make you familiar, if you haven't thought about this stuff in a while, right? And solving various types of algebraic equations, you might have to do cubed roots, etc. Okay, we can come back to that. If you have questions on that, feel free to post them in the chat. Properties of exponents, right? So sort of related, in addition to cube terms and cubic roots, or square terms and square roots, you have other properties of exponents, right? And you need to know when you see something written, 5, or we could do 2 to the 3rd times 2 to the 4th, okay? When you multiply things of the same base, okay, all of these base belong to us, right? They're both 2, the same base. So I add these exponents. So if it's the same base, then I add the exponents, and this becomes 2 to the 3 plus 4, right? 2 to the 7th, okay? That's what this is saying. A to the x times a to the y is the same as a to the x plus y. And you could check this if you want. 2 to the 3rd is 8. 2 to the 4th is 16. 2, 4, 8, 16. Okay. 16 times 8 is 128, which is 2, 4, 8, 16, 32, 64, 128, 2 to the 7th. Yep, story checks out. That looks good. Okay, Now, if you're dividing these terms, right, 2 to the third divided by 2 to the fourth, okay, you subtract the exponents, okay? This is 2 to the 3 minus 4, 2 to the negative 1, okay? Negative exponents mean, right, it's a reciprocal. 2 to the negative 1 is 1/2. 3 to the negative 1 is 1/3, okay? These are the types of things you need to do like rapid fire throughout General Chemistry 2 and throughout the math quiz. Okay, so if any of this makes you uncomfortable, ask for extra practice problems at the end, and we can do these. Okay, so this is properties of exponents, whether you're multiplying or dividing things of the same base. Okay, you might also see this, 2 to the 3, right? We can actually write it in here. 2 cubed, all of which, with parentheses, is raised to the third power. Okay, up here, we added these exponents when we were multiplying things with the same base. We multiply the exponents when we are raising one exponent to the other, okay? So this is the same as 2 to the power of 3 times 3, right? 2 to the power of 9, okay? So 2 cubed, quantity cubed, is the same as 2 to the power of 9. And this is probably 512 if I had to guess. 2 cubed is 8. 8 cubed is 8 times 8 is 64. 64 times 8 is 512. So yes, this is the same as saying 8 cubed is the same as saying 2 to the 9th. Okay, so those are the properties of exponents I expect everybody in General Chemistry 2 to know. These are the square roots, and you should be able to know how to solve for things that are squared or cubed with cubic roots or square roots. Okay, now, logs and natural logs are probably the thing that give the most students trouble in General Chemistry 2. Okay, so when you see log of x, right, usually you should have a little 10 down here to tell you it's the base 10, but a lot of times it's just the default is that it's base 10. Okay, so log of x, basically the default is it's a base 10, right? Which means, you know, if I have log of x is y, this is the same as saying 10 to the y equals x, right? The base is this number. It should be written here, but a lot of times it's not, okay? So that's how logarithms work, right? If you wanted to say log of 1,000 is asking us, okay, log 1,000 equals y. Well, this is base 10, so it's 10 to the y equals 1,000, okay? And y is 3. 10 cubed equals 1,000. Now, what you're apt to be asked to do in general chemistry is solve some algebraic expression like this with your calculator, right? In the same way I would ask you to solve for this, 5x equals 2, you would say, well, algebraically, I have to divide both sides by 2. Yep, x equals 2/5. Story checks out, okay? In much the same way when we're solving logarithms, you have to undo the log, right? What is the reciprocal of the log here in this analogy, okay? And it's taking 10 to the power of on each side, right? 10 to this side cancels the log. 10 to this side is our answer. So x, now that we've canceled it, x is 10 to the third. X is 1,000. Okay, so that's the sort of context where you'll be probably encompassing logs throughout the class. Natural logs, ln, all the same properties, okay? You've just taken this base 10 and you've substituted it for this magical number e, right? On your calculator, find it, love it, know where it is. Because if you incorporate something like this, ln x equals 3, right? This isn't, 10 to, that's not how I'm canceling natural log. Natural log is a base e, so I take e to the power of to get rid of this. And so x here is e cubed, okay? So e is a number on your calculator, find it. Its exact number to 9 digits is 2.71828. 1/8, etc., etc. All right, this is part of like the golden ratio in mathematics. Okay, so this is, you don't have to memorize the number, but be familiar with how to use it. Will encompass exponentials, right? That look like this, e to the negative 5 over RT, right? Equals 2, solve for t, right? And if you have to solve for t here, the first thing you have to do is get rid of this e, so you take natural log of it, right? And much the same that you get rid of natural log by raising e to the power of, you get rid of e by taking natural log of, right? So you would take natural log of both sides to get rid of the e, and now you have negative 5 over RT equals this number, ln of 2, right? You can do ln of 2 on your calculator, and now you've reduced this 0.693, and now you've reduced this to a simple algebraic problem you can solve, right? Solve for t, r is the gas constant, you plug that in, do some reciprocals, and solve for t. Okay, so these are the kinds of things you're likely to encompass or likely to encounter in general chemistry 2, right? Solving for x when there's a natural log or a 10 to the power of, right? Or where there's a natural log or an e. So just know these sort of reciprocal approaches for solving and what natural log and log really means. Now, we will also encompass properties of logs. And properties of logs are the following. There's more, but these are the useful ones for this class. Okay, properties of logs look like this. Log of quantity a times b. So you always see parentheses or brackets out here, right? And so pay close attention to where the brackets are and what they're separating, right? Log of quantity a times b is the same as log of a plus log of b. Log of a over b is the same as log of a, enter, minus log of b, enter. Okay, so log of a times b over c, right? Log of a times b over c, okay? That's different than log of quantity ab divided by c. Okay, so pay attention where the parentheses are open and close for how you might organize or rewrite this formula. Okay, so log of quantity AB over C on the left, right? Log of two quantities multiplied is the same, this is part 1, as writing log of A, close parentheses, plus log of B, close parentheses. The denominator here, divided by C, is using this, minus log of C. Okay, so that's what this example is showing right here. Okay, when quantities are multiplied, we can factor them out and add the logs together. When they're divided, we can factor them out in essence and subtract the logs. And you can have both in one, like here, A and B multiplied while C is divided, and separate each of those out. Okay, the last one is a property of a log when you have a power inside the parentheses.
Good news, everyone.
Okay, when you have the parentheses, a power inside the parentheses, okay, what you can do is basically move this exponent out in front. And you could prove this if you go back and think about it being base 10. We don't need to worry about that, but from properties of exponents and powers. But basically, this moves out front. Okay, and this is really, really useful in solving algebraic expressions in general chemistry too. Okay, so log of 2 cubed is the same as typing into your calculator 3 times, we'll use brackets here, times log of 2. Okay, that's what we want. So that's properties of logs, right? Dealing with logs and natural logs, properties of exponents, square roots, cubed roots, higher order roots. Okay, all of this is sort of a lot used in solving equilibrium problems and solving kinetics problems and rearranging algebraic expressions. Now, the last is quadratic formula. Okay, quadratic formula, perhaps you've memorized. I have a little sing-songy way to do it. So repeat after me. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Again, x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay? Now, we're going to use this in several equilibrium problems, titrations, that sort of thing, right? A here is the constant in front of x squared, right? Which appears here, the formula, and here. Okay. B is the quantity in front of the linear term, the first power x, and that appears here, and it gets squared, and here. Okay, and C is the constant in the formula. So what you're going to have to do several times, you're going to have this quadratic equation. You have to get everything on one side, so it's of the form something squared, something x squared plus something x plus a constant equals 0. So you get everything on one side, and then you plug in the quadratic formula. Now, you will have, okay, this note, caution, this yields two values because there's a plus and minus here. And we'll do an example shortly, right? This yields two different values, plus and minus, one of which will make sense, one won't, okay? Now, on the math quiz, you might have to identify both, okay? But in the context of chemistry, if you get two solutions, usually only one of them will make any sense. Now, I will warn you, in this class, okay? In this class, erase some of this, if this quantity in here comes out to be negative, so you take whatever b is here, you square it, and you subtract from that 4 times a times c, okay? If this quantity is negative, you'll have a square root of a negative number. And a square root of a negative number in this class, okay, is dead to us. Okay, that is not a real solution. It is not a real number. It doesn't matter for the intents and purposes of this. We call it an imaginary solution, right? It's not of any real consequence. It's not going to be used to solve real chemistry problems in this class for the benefit of humanity. So we would state there is no real solution in that context. Okay, so in solving the quadratic formula, if you get a negative number inside the square root, you claim there is no real solution. In other cases, you get a positive number and it'll yield two values, one from the plus in the formula and the other from the minus in the formula. There will be two solutions. One of them probably makes more sense than the other in the context of chemistry. So let's try one of these, x squared minus 2x minus 24. I've already arranged it, nay. Okay, pretend like this didn't exist. Pretend like the formula was x squared equals 2x plus 24. Okay, solve for x. And you go, aha, I remember that I need to put it in quadratic formula terms. And so I subtract 2x and 24 from each side to be left with this. And now I have a 1 right here. Okay, I have b negative 2 right here, and I have c right here, negative 24. Okay, and now I'm capable of plugging each of these in, right? X equals negative of negative 2 is positive 2 plus or minus square root b squared, so negative 2 squared is 4 minus 4 times a is 1. C is negative 24, okay? All over 2 times a is 1. Okay, so I can rewrite this. I have 2 plus or minus the square root of 4 minus 4 times 24 is 96, or minus negative 96 over 2. So I have 2 plus or minus 4 minus negative 96 is 100 over 2. Okay, so I have 2 plus 10 over 2, and 2 minus 10 over 2 are my solutions, right? 12 over 2 is 6, plus 6. 2 minus 10, negative 8 over 2 is negative 4. So the solutions are x equals plus 6 and minus 4, right? So this would be the same as writing x minus 6, x plus 4 if I were to unfoil this formula, right? If I foiled this, I get x squared minus 2x minus 24. Now, some of them will not work out to be such nice solutions. There'll be a bunch of decimal answers, so you won't always be able to like foil it in your head and figure it out. So stick to the quadratic formula. Okay, if x was a concentration of something, well, we would choose the positive number because, molarities and concentrations of things aren't negative. Okay, but in terms of the math quiz that you're about to take, that this review session is for, right? The solution here that you would select is x is plus 6 minus 4. If something in here was such that it came out to be a negative square root, you would select no real solutions. Okay, if it's something simpler like this and you can factor it, fine, but usually in chemistry it's not going to be the case. Okay, the last thing that I'm going to touch on here is dimensional analysis. Okay, I expect you to know how many millimeters are in a centimeter, how many kilometers are in a meter, these basic types of metric conversions, okay, and how to convert them, how to do dimensional analysis, right? So convert 53 millimeters to kilometers. This is basic dimensional analysis. This is clearly a prerequisite skill you should know, right? 1,000 millimeters in a meter. Okay, 1,000 meters in a kilometer. One, two, three, four, five, six. So this should be the answer. Okay, so know how to do simple unit conversions like this. Compound units, right? 50 miles per gallon to kilometers per hour. Sorry, 50 miles per hour to, say, kilometers per second, right? Or 50 miles per gallon to kilometers per liter. Now, I don't expect you to know how many miles are in a kilometer, right? Or how many liters are in a gallon offhand. I do expect you to work out hours and seconds in that relationship, but I would give you conversions for, say, miles to kilometers if you needed it. I expect you to know the metric ones, not necessarily metric to English. Okay, so a dimensional analysis for those compound units. Squared and cubed units, right? You should know how to do 22 centimeters cubed to inches cubed, right? I'll provide you with, although I shouldn't have to, I'll provide you with 2.54 centimeters in an inch, right? But if it's cubed, you have to do that conversion 3 times. Okay? You also know that if I want you to find the volume of a rectangular solid, look at this perfect rectangular solid here, right? That is 3 inches by 4 inches by 7 inches, nay, 17 centimeters. Okay. I'm not going to do 3 times 4 times 17. I better convert this into inches first before multiplying. Okay, so that's the only other thing I would say is, if you're given a couple dimensions in 1 unit and another dimension in a 3rd unit, make sure you're converting that 3rd unit, right, like the others before you start multiplying all these numbers together. Okay, so this is basic dimensional analysis. Okay, and that sort of finishes the types of topics in the past 25 minutes or so. We discussed that I expect you to know for the math quiz. There will be other subjects on there that are somehow related to this, maybe easier than these, but these are a lot of the concepts that you need to be able to do and do quickly to solve many of the problems on the math quiz. One more, okay, is graphs and reading graphs, okay? And remembering what linear means on a graph. So if I have a graph like this, and say I'm plotting, right, on the y-axis, 1 over concentration of A. And maybe on the x-axis, I'm plotting time, okay? And maybe this is the line. It looks like this, okay? And the equation for this line looks like the following. 1 over A equals, right, kt plus a concentration of A naught, okay? It's not important you know what all these terms mean or what they stand for, but what I expect you to be able to do, okay, is tell me what is the slope. What is the slope of this line? Here's the equation of the line. Here's the graph. What is the slope? And this linear formalism, y equals mx plus b, okay? This is my y because it's on the y-axis. The y here is 1 over a. The x, right? Sorry, this is t. The x here is t. Okay, so my y is this, my x is this, which means the slope is just whatever's written right before the x term. Okay, the slope is k. Okay, the y-intercept is whatever this means, brackets a with a 0. Okay, this stands for initial concentration. We'll use this formula and this graph exactly when we cover kinetics. But right now it's just about the math of understanding what is the y-intercept, what is the slope for something like this. Okay, so those are the topics I would expect you to know, and you'll see problems like this on the math quiz.